This video is about the coordinate plane, specifically distance and midpoint formulas. So when you're working with the distance formula, first you need to know how to enter in a square root into a calculator. So let's say we're doing square root of 30. On most of the assignment, it's asking you to go to the tenths place. So that means 1 decimal place. So for that, we're going to need a calculator, and they do provide a calculator for you to use in the program. So let's go to that calculator. So I've brought the calculator up. Usually there's some sort of calculator button on the screen when they think you'll need to use a calculator. So using this program's calculator, for this program, first you hit the square root button, then you hit the number 30, then you hit enter or equals. So if we're going to 1 decimal place, that's the 4, we have to decide if we leave it as a 4 or round it up to a 5. So since the number next to it is a 7, that's 5 or bigger, so we round the 4 up to a 5. So going back to our assignment, or our problem we were working, then the square root of 30 would be 5.5, approximately. So usually they use the squiggly lines. So it depends on your calculator. Some you hit the square root button first, then enter the number, then hit equals. Some you'll hit 30 first, then hit the square root button, then hit equals. It depends on what kind of calculator you're using. So the distance formula itself will take any line drawn on the coordinate plane. So the coordinate plane is a set of axes that we've divided into sections. Quadrant-wise, each corner is considered a quadrant. So like this top right corner would be quadrant 1. Top left would be quadrant 2, bottom left would be quadrant 3, and bottom right would be quadrant 4. So on that coordinate plane, they'll give you some points. Let's say we have the point x at the coordinate -1, 2, and the point y at the coordinate 3, 4. So to graph each of those, we know they go in order as an x-coordinate and a y-coordinate, so -1 is in the x direction. Here's the x-axis, here's the y-axis. So -1 means go left 1. We have to find -1 on the x-axis. And then +2 means go up 2 from there. So there's our first point. Y is 3, 4, so we go right 1, 2, 3, up 1, 2, 3, 4. Now since this line is diagonal, there's no way for us to just count the distance. We have to actually use some sort of formula to calculate the distance, and that is called the distance formula. So the distance formula is d for distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. Now they label this x with a little 2 below, x with a little 1 below for a reason. That's because they're both x values on some sort of point, but they're different x values. So like looking at this point, -1 is an x value, but so is +3 on the second point. Those are both x values. So we have to know, well, how are they different? Well, this first one is from the first point, so let's put a little 1 underneath. 3 is from the second point, so let's put a little 2 underneath. Then we look at the y values. 2 is a y value, 4 is a y value. 2 is from the first point, and 4 is from the second point. So now we're going to go and replace every single variable with the number that it's associated with. So according to the formula, we still have the square root symbol. x2, we still have a parentheses. x2 was 3. Then minus from the formula, that negative sign here in the middle comes down. x1 is negative 1. So we end up with a minus right next to a minus sign. Squared plus y2 is 4 minus y1 this time is just positive 2. So this time we do not end up with a minus minus. So now we have to follow order of operations to simplify this. First, we combine what's inside the parentheses. Well, if we have minus minus, this all really just changes to a plus sign. So we'd get d equals 3 plus 1 is 4 squared. 4 minus 2 is 2 squared. 4 squared is 16. We do our exponent next. Squared means multiply it by itself, so 4 times 4 makes 16. 2 squared would mean 2 times 2, which is 4. Add those together, which is square root 20. And now we have to plug it into a calculator in order to figure out what is square root 20 approximately. So back to our calculator. So looking at this, we already have something in, so to get it out, I put C to clear. Square root 20, and then I have to hit equals for it to calculate. 4.47 if I'm rounding at the first decimal. 4 will round up to a 5 because the number next to it is a 7. So that means our answer would be approximately 4.5. So next is the midpoint formula. So distance, if it finds the entire length of the line, the midpoint formula is just going to find the coordinate that's halfway on the line. So midpoint formula, sorry I keep moving the box instead of scrolling down on accident. Midpoint formula is actually 2 formulas in one. We go x2 plus x1 divided by 2. That's the formula for just the x coordinate. And y2 plus y1 over 2. So to find, and we can kind of split these up actually into 2 formulas. To find the x midpoint, it's x2 plus x1 over 2. And to find the y midpoint, it's y2 plus y1 over 2. This one is more useful if you're actually finding the midpoint. Over here on the right, these formulas are more useful if you're finding an endpoint. So let's try a problem. Let's use the same coordinates we did last time, but this time instead of finding the distance, let's find the midpoint. So we had the coordinate -1, 2, and 3, 4. Sorry, that dot was an accident. I was just trying to point as I was counting. And we want to find this point exactly halfway. Now you can kind of eyeball it and say, well, it's going to be close to 1, 3. But we need to check for sure. So our coordinates were -1, 2, 3, 4. Now same idea, this is still x1 and y1, the x value and y value from the first point. And this is x2, y2, the x value and y value from the second point. So now we plug these into the midpoint formula. So x2 was 3 plus x1, which is -1, divided by 2. y2 is 4 plus y1, which is 2, divided by 2. Now to simplify this, we add what's in the numerator first, and then we do our division. 3 plus negative 1 is 2. Four plus 2 is 6. So now we actually divide. And if it gives you a decimal, that's fine. We'd want to just plug this into a calculator and get an answer. 2 divided by 2 is 1. 6 divided by 2 is 3. So this would be the midpoint. That would be the coordinate 1, 3. So our eyeballing it was pretty close, but again, it may be like 3.5 or something, so you need to plug it into the formula to know for sure. So the last type of problem is if they give you the midpoint and one endpoint, and you need to find the coordinates of the other endpoint. So the midpoint of xy is m 4, negative 6. The m just stands for, hey, this is the midpoint, and that's the coordinate. One end point is x 2, negative 3. Again, that's just saying this coordinate 2, 3 would be labeled as x. Find the coordinates of the other endpoint. So it helps me if I can visualize it. You don't necessarily have to graph these points, but for me, that helps me see the bigger picture. So first we have the midpoint, which was 4, negative 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Then we had a coordinate 2, negative 3. Write 2 down 3. So because that purple dot is the midpoint, it's halfway, the other endpoint should be somewhere in that direction. So this coordinate was 2, negative 3. It is labeled as x. And this coordinate was the midpoint, and it was 4, negative 6. And we have to find this last coordinate. So this is where using the separate equations can be helpful. The x-coordinate of the midpoint was equal to x2 plus x1 divided by 2. The y-coordinate of the midpoint is y2 plus y1 over 2. So we know m stood for midpoint. That means this is actually x sub m. It's the midpoint's x value and the midpoint's y value. X coordinate is either x2 or x1. It doesn't really matter. I'm going to say x1. And y1. Sorry, that's a 1. And then what we want to find is the other endpoint, so x2, y2. So what we want to find is going to stay as a variable. Everything else we're going to plug stuff in. We said x sub m is the x-coordinate of the midpoint, so 4. X sub 2 we're looking for, so I'm going to leave it as x sub 2. X sub 1 is 2. Do the same thing with y sub m. We know y sub m is negative 6. Y sub 2 we're looking for, so we leave it. And y sub 1 is negative 3 divided by 2. Now to solve something like this, first we're going to have to times both sides by 2. What that will do is, because dividing by 2 and multiplying by 2 are opposites, those will cancel. We'll get 8 equals x2 plus 2. 2 times 4 made the 8. I'm going to put some lines just to show these are all separate. Now we have to finish solving this. This is plus 2, and we have to do the opposite, which is minusing 2. That means x sub 2 equals 6. That's the first coordinate of our endpoint. Now we do the same thing with the y's. We times both sides by 2. Opposites cancel. 2 times negative 6 is negative 12. Now it's plus a negative 3, so we're actually going to have to add 3 to get rid of this. The opposite in this case would be adding 3. Negative 12 plus 3 is negative 9. So that means our coordinate of our endpoint would be 6, negative 9. Now you can double check it by saying, well, does that look like it's in the right spot? If I went right 1, 2, 3, 4, 5, 6 and down 6, 7, 8, 9, I did a pretty good approximation. That does look correct. So that ends our discussion on distance formula and midpoint formula.